Thank you, everyone, for coming. I'm Alberto, but you can call me Albert. I'm from Spain, and today I'm going to speak about SOQL performance explained. So that's me. Here you have my contact details, my Twitter, and my mail. If you want to ask me anything, please don't hesitate on using them, and I will answer as soon as possible. I'm a senior developer in FinancialForce. FinancialForce is a great company in Salesforce. Indeed, we have the #1 cloud ERP on Salesforce, and we have more than 700 employees. Indeed, we are looking for new employees for Harrogate office and Granada office, where I'm from. And here we have the main headquarters in San Francisco. And we have more than 1,400 customers in more than 34 countries. And this is the end of my advertisement. So let me start. That is my agenda. I broke up my presentation in several points. First of all, I'm going to give an introduction. I'm going to give you an analogy to clarify or to try to clarify all the concepts that I'm going to see during this presentation. Then I'm going to speak about the query optimizer, how the query optimizer works. Then we will continue speaking about the indexes, what is the indexes that Salesforce create automatically for us. And then I'm going to speak about the selectivity. What is the selected query? What is a filter, a selected filter? And what is the threshold that Salesforce defines and the exception that we have to avoid when we are writing a query? Then I'm going to do a little demo to clarify all these concepts. And we will continue giving another 2 tools to improve the performance in your queries, the sort optimization and the skinny table. And in the end, I'm going to give you a summary of all my recommendations that I'm going to provide you during this presentation. So let me start. The Jesus map. Okay, when I started to prepare this presentation, my first consideration was how to explain it in 30 minutes in order for you to live with a good understanding on how to perform your queries. So I don't like to follow the definitive guides or promote the golden rule to achieve something. I think that there are many ways to do something and do it well. So I decided to use an analogy, the ship analogy. So try to think in the captain, or try to think about the captain of a ship. He can steer his ship following many routes to arrive at a certain point. He uses a compass to guide him and a navigation chart to warn him about the obstacle that could sink his ship. In the same way, I'm going to provide you, or I'm going to give you some helping tools to improve the performance in your queries. And I'm going to advise you about the obstacle, places, or things that you have to avoid when you are writing a query because you could sink your query. So let me start. Okay, the query optimizer. First of all, I want to explain how the query optimizer works. It's not the main goal of this presentation to try to understand how the query optimizer works. Indeed, Salesforce doesn't provide any documentation about this topic. And it isn't completely necessary either. But if to be a good Formula 1 driver, it's necessary to know how the car engine works. For being a good programmer or to make efficient queries, it's necessary to know how everything works at a low level. So the query optimizer follows the following flow. First of all, run pre-queries. In this step, it would check the user visibility and the filter selectivity, then search the best index where run the query, continues determining where is the best table from where run the query, unless there is a good index available, then continue sort the rest of the table to minimize the cost, minimize the joins between tables, including the foreign keys to minimize or to make efficient joins, then including the sharing joins to minimize the inputs and outputs from database, and in the end, update statistics. Because of the Salesforce nature, the Salesforce stores its own statistics to help to the database to choose the best way to access to the data. And this statistics is stored nightly. And this is more or less the picture, shows the way with SafeForce used to organize the information. And take into account that the standard fields and custom fields for a standard object is split in separate tables. Because in the end, more or less, of this presentation, I'm going to give you a tool to join all this data in just one table and minimize the joins between tables. Multi-tenance is a means of providing a single application to multiple organizations from a single software-hardware stack. And SafeForce stores all the virtual tables and all the virtual information in a few large database tables, partitioned by tenant, and serve as a heap storage. And to data to be searched, it must be searched, it must be indexed. And that indexes are created using the search indexing server, which also index all the records and manage all the queue entries of newly created and modified data. So SafeForce split or use separate tables, one for the index table and another one for store the data table. I love the analogies, so I continue with my analogies. Because try to think, for example, where you are trying to look for or find something in a book, you don't read page by page looking for example, when a chapter starts. You usually go to the book index, search where is this chapter, and this book index redirects you to the appropriate page where this chapter starts. In the same way, the database works similar because the best way to look for something is first search in the index table, and the index table redirects you to the appropriate records in the data table. Take into account another thing here is SafeForce index null values by default for standard indexes. But don't make the same with the custom indexes. So we can ask to the SafeForce support to index null values for us in the custom indexes, but by default it's not indexed because this is another thing that we will retake later. And that is the indexes that SafeForce create automatically for us. So ID name or need ID, created date, and system mode stamp are standard indexes, are standard fields, and therefore standard indexes. And master detail lookups, and so on, etc. We will index it independently, whether they are standard fields or custom fields. And what would it happen with the rest of the fields? Okay, keep calm, don't panic, because we can ask a SafeForce support to create an index for any field except those ones. We can index multi-select pick lists, text areas, either long or rich, encrypted text field, and non-deterministic formula field. What does non-deterministic formula field? A formula field is non-deterministic when its value depends on another value. For example, today function is a dynamic date dynamic function, and its value is continuously changing. So the SafeForce platform can be realistically maintained index a function which its value is continuously changing. So the most common example of non-deterministic formula field are use of time or date dynamic functions and reference to other entities or to other formula fields. But there are only some common examples. So I highly recommend you that before to use a formula field to embed your logic in your query in a formula field, try to read all the documentation that SafeForce provides about this topic to consider if your function in your formula field is deterministic or not. Could you hear me well? Yeah? Okay. Here, for example, or here my tip is, instead of embed your logic in a formula field, embed your logic in your queries, in your reports, and in your list views. So, for example, instead of write the today function in a formula field, we can use the last end day function, which is owned to the SAFeForce object query language. And in that case, we can use, for example, the close date index for look for the information that we are looking for in a database. And the selectivity, okay. We are going to retake the analogy that I mentioned at the beginning, because that is our compass. It's our best tool to improve the performance in our query. So if we want to, or what is a selective query? A query is selective if it has at least one selected filter. And what is a selected filter? A filter is selective if it has at least one index in the word clause, and that index follows with the conditions of selectivity, the threshold that SAFeForce defines depending on the kind of index, standard or custom, and the kind of operation that we are using, compose index, union index with or like. And I'm going to spoil you because the like is not our friend. So, a standard index will be selective if it complies with these rules. Return up to the 30% for the first million of records, the 15% of records after the first million, and it returns up to 1 million of records. Okay, we are going to clarify all this concept with the demo later. But for the custom index, we have the third of the condition of the threshold that we have for the standard fields. So here, we can return up to the 10%, the 5%, and the third of 1 million records. And what would it happen with the compose index or union index? Okay. For the compose index, we can return up to the twice of the selectivity threshold for each filter, but in the intersection, we can comply with the condition of selectivity. So, for example, if we are writing a query in our clause using two standard indexes with an AND operation, we can return up to the 60% for the first million for each one, the 30% for the rest of the million, and it returns up to 2 million of records. But in the intersection, we should follow the rules or the condition of selectivity that SAFeForce defines. And the union index is so close. But in that case, we don't have the double for each filter. We can always comply with the selectivity threshold for each filter and in the union also. So, and the like, okay, SAFeForce considered to use a like operation or consider to use an index with a like operation checking the first 100,000 records. Always that the string doesn't start with a wildcard. But as I mentioned, the like is not our friend, because if we don't comply with one of two rules, the query optimizer doesn't consider to use our index to execute our query. And another option is we'll execute our query doing a full scan of the data table. So now I'm going to, retaking again our SIP analogy, I'm going to advise you about the obstacle that we have to avoid when we are writing a query, because if we do one of the following exceptions, the query optimizer doesn't consider to use the index to execute our query and execute our query doing a full scan of the data table. So the first one is using wildcards. And take into account that in reports and in list views, the contains function is translating as wildcard, string wildcard. So my tip here is when you need to use wildcard, use SOQL, the another language that SAFeForce provides for this kind of operation and is more appropriate for this kind of queries, the SAFeForce object search language. Another exceptions. Using negative operator with filters like distinct, exclude, not like, not, is another obstacle that could sink your query. So try to avoid to use this kind of operators. And the example is simple. Try to think, for example, that you are looking for in a book index, one chapter distinct to some string. You have to read all the book index before to finish to search what is the chapters comply with this condition. So in the same way, if you are looking for some index distinct to some value, you have to read all the index table. And it's so probable that you have a relationship one-to-one between your index table and your data table. So the query optimizer, instead of read all the index table and then set the appropriate records for these indexes values, doesn't consider to use the index. I will execute our query doing a full scan. So my tip here is use filters with equals or in operators. For example, instead of write a query like get the cases where status is distinct from close, we can say, for example, get me the cases where status in all the statuses distinct from close. And in that case, maybe we can use the index, the status index, always that we comply with the condition of selectivity. Another obstacle that could sink your query is comparing text with the forbidden operators. So try to avoid comparing text field with lower, greater, etc. And the example is so close to another one. And comparing with null when it's not indexed. So as I mentioned at the beginning of this presentation, SAFE4 index null values by default for standard indexes, but we should ask to the SAFE4 support to index the null values for custom indexes. So if we are using, for example, a custom index like a stage name, that custom index doesn't have the null value indexed, the query optimizer doesn't consider to use that index and will execute our query doing a full scan again. And we are going to see a little demo to clarify all this concept. So, okay, I've created a bunch of data. I've stored 100,000 records in opportunity object. And here we have two aggregated queries. The first one is aggregating by the close date custom index, a standard index, sorry, a close date, by calendar year, week in year. And this another one is aggregating by my stage name, is a custom index. So SAFE4 provides us with a helping tool, the query plan API. And by default, it's disabled, but we can enable here, click in Help Preference and check this checkbox. And when we do that, it's appear here, another button, the query plan. And we can use the query plan button to help to know what is the decisions that the query optimizer considered to use to execute our query. So, for example, I'm going to execute our query, this query, get the opportunities where close date is the current week with the query plan. And it's so probable that the current week has between 1,000 and 3,000 records. So if we remember, the condition of selectivity for a standard index is return up to the 30% for the first million, 50% for the rest of the million, and it return up to 1 million of records. So it's so probable that we comply, well, we comply for sure with the condition of selectivity for the current week because we are return lower than the 10% for the first million. And the query plan saying the same. The query plan shows all the options that the query optimizer considered to use and is ordered by default by the cost, okay? And in that case, the best option with the lowest cost, is use the standard index from close date. And the another option is execute our query doing a full scan. But what would it happen if we're looking for example, the close date lower than date? In that case, we are returning all the data from this object, all the information, all the records. So in that case, using the index is a worse option than execute our query doing a full scan, because we are returning more than the 30% of records. And another example with a custom index. So we are looking for opportunities where my stage name is proposal price quote. And proposal price quote, if we remember, the condition of selectivity for custom indexes is return up to the 10% of the first million, 5% for the rest of the million, and so on. And we are returning here for the proposal price quote lower than the 10% for the first million. We are returning lower than 10,000 records. So if we use the query plan API to execute our query, the index is the best option to execute our query, because we are comply with the condition of selectivity, and the cost is lower than doing a full scan. But instead of look for the proposal price quote, we are looking for the prospecting. And in that case, we are returning more than the 10% of the first million. And in that case, doing a full scan is a better option than use the index, the custom index from my stage name. Take into account that the query plan API is not a very precise tool, because it's only a helping tool. Okay? Remember that, because look that the cardinality that shows in that case is saying that it returns 15,000 records, and that is wrong, because we are returning this number. Okay? So remember that the query plan API is only a helping tool to try to understand what is the decision that query optimizer considered to execute our query. This is another option. Now I'm going to see the exceptions, the obstacle that could sink our query. So in the first case, I'm comparing with a null value, a custom index, which is not index that value. So the index is not an option to execute our query. The query optimizer only considers to execute our query doing a full scan. And in the notes, it appears more or less an explanation about that. Not considering filter of optimization for optimization, because not valid index is for filter. Another exception. Comparing with a negative operator, again, the index is not considered to execute our query, because the operator is not optimizable. And comparing a text field with one of the forbidden operator, again, it's not considered to execute our query. And the last one, comparing or use a like operator. And in that case, okay, it's considered to use the index, but look, the cost is the lowest, is the worst, that we are see in this demo. So try to avoid to use the like operator and comparing with wildcard text field. And now I'm going to speak, or I'm going to give you another two tools to improve the performance in your queries. The first one is the sort optimization. Okay, try to think, for example, that you are in a scenario or in a situation that you can reach the condition of selectivity for execute your queries. So in that case, you can use the sort optimization. And the sort optimization consists in order by an index. And the first two questions that everyone asks themselves, including me, when we see for first time this optimization is, okay, but if I add an order by an index, I'm increasing my condition of selectivity, my threshold for my index? No, it doesn't. So, but if I include an order by clause in a query, I'm going to increase the execution of time because I have to order the results of my records after two searches in a database. No, it wouldn't. Both questions, the answer of both questions are no. Because when we order by an index, we are telling to the query optimizer to start to analyze the records from the top or from the bottom of the table because the index table are ordered by default. So when we use the order by clause bound with a limit clause, and it's so probable that you have a limit clause in your queries for not hitting with our worst enemies, the governor limits, the query optimizer starts to analyze the index table from top or from the bottom of the table, depending ascending or descending order, and including the results in your in the return. And when the limit is reached, stop to analyze more records. And we have to take into account some considerations with this optimization. First one, only works for number and date fields. And if we use a two-column index, we have to filter for the first one and excluding the null values and using an equal operator and sort by the second one. So we have to exclude the null records and please evaluate the optimization before to use the sort optimization because there are some scenarios that we can reach a good work with deep optimization. I can think in two scenarios, for example. Try to think, for example, that your limit is greater than the records that you return at the end. So you are reading all the index table before to return at any results. So you are not improve the performance in anything. And another scenario is that you are looking for records that is not close from bottom or the top of the table. So you have to read a lot of records before to return anything. So you are not improving anything or as you like. And the last one tool is okay, try to think, for example, that the sort optimization doesn't work, you can't reach the condition of selectivity. In that kind of scenarios, when your customer is complying continuously about the slower and slower and slower functionality of your application is use a skinny table. In that case, the skinny table is our friend. So, as I mentioned at the beginning of this presentation, a save for a split a standard field and custom field for a standard object in separate table. But we can ask to the save for support to create a new skinny table. That skinny table has all information in just one table. And because we have all information in just one table, minimize the number of joins because we have all information in just one table. And the skinny table is synchronized with the source data by default. And the most important for me, the soft-deleted records are not included. And that is important because it's something that I didn't mention before. But when we are looking for something in a database to consider to use or to read the data table, consider the active records, the records that you have active in your application, and the soft-deleted record, the records that you have in your SalesForce bin. So it's more difficult to reach the condition of selectivity with information in your SalesForce bin. But the skinny table doesn't consider this kind of records. And as Spiderman knows, a great power carries a great responsibility. And there is some risk that we have to take into account before to use a skinny table. A skinny table should be skinny and should contain the minimum number of fields. Okay? The maximum number of fields is 100. When we modify the field type in the source, for example, change a date field for a number field, we have to create a new skinny table, recreate, okay? And it's not copied in sandbox.org. So when all is fails, use a skinny table. And that is the summary of all the tips that I provided you during this presentation. My last tip here is the best way to lose weight is to avoid gaining it in the first place, okay? So it's so important that try to search only the fields that you need in your select clause, be as restrictive as you can in your word clause, and the most important, if you don't need some information in your database, try to do a hard deleted or move to another third database or another way, because it's easier to reach the condition of selectivity and easier that the query optimizer consider to use your indexes. Okay, and that's all. Thanks. Is there any question? Any doubt? Yeah? Could you use the microphone? No. Could you use the microphone?
If you have to use the mic question and
Ah.
Well, he's.
Okay.
I got a question. Internally, we have this debate, like number of fields that get returned on a SQL query.
Could you speak louder, please?
Oh, sorry. On a SOQL query, the number of fields that get returned, does it matter, like how many fields, you know?
In your select clause?
Yeah, select
Yeah,
clause.
it's not important. Yeah, it's true. But if you have more select fields, you have to get more information from your database. The execution time is increased. It's not. It doesn't have to be anything with, or it's not related, the select clause, with the condition of selectivity, but it's important because it's less information that you have to cache in your list to return to your customers. Yeah?
Yeah, I was wondering to what extent those advice apply to SOQL queries for the word clause, for example.
When use the SOQL?
Yeah, no, I mean, all the examples that you gave about indexes and filters in the where part, do they apply to as best practices for SOQL queries?
Yeah, I'm not, I don't sure about that because I don't use a lot of the SOQL language, only in that case, but if you give me your mail, propose me to study a lot.
That's
and
perfect.
I'll send you.
That's very cool.
Sorry.
Thanks.
Sorry.
Hi. You talked a bit about combined field selections when you started. I mean, if you have a select on two different fields. But do I understand right that the basic select will always be on one field? Or can two index fields be combined to improve the selection?
With a compose index, for example. Are you asking me if, for example, you can use a compose index to consider to execute our query? Or?
Yeah, so I mean you have two fields on which you want to do the select, and combined they will be in the threshold of 10% or 20%.
Okay, the threshold of the compose index.
Will they add performance? Will they both be executed, or will only be the best index field be executed?
So, if I understand you, you are asking me what way works for example, the union index or the compose index with an AND operation when we combine with two index with an AND operator. Yes. Okay, I can show you. For example, okay. In that case, SafeForce considered to use the first index, the custom index. The another one is the close date, is the standard index, and the other is the compose index. Okay? The other option is the compose index. And in that case, it's considered to use the three cases, but stop to analyze because the my stage name, in that case, take into account that stop with the 20,000 records, the double of the condition of selectivity for custom indexes. Because in that case, we have the double, the twice of the condition of selectivity for each filter. So, but the sum of prospecting and qualification for my stage name is greater than the 20%, and that's why doesn't consider to use the compose index. So it's another option to execute our query. Consider one index, another, and the other options is use the compose index. Yeah, it's clear.
Does this mean other is always to do with composed indexes, or?
The other is the compose index, yeah.
That's always the composed index.
Yeah, no, yeah. If, for example, we included an operator, the other is the compose index. And if we added an OR operator, maybe consider to use the compose index and the union index also. Okay. So that's all. Thank you for coming.